Before the first sunlight crests the curve, the horizon is already writing questions only the day can try to answer. We raise our eyes to the aurora and stars, certain the visible world is the whole story we have to tell. For thousands of years, patterns traced in light have been our compass, guiding journeys across land, sea, and sky. Yet every gaze, no matter how sharp, is bound by the finite reach of light into the dark. Perhaps the truest shapes in the cosmos are sculpted where no light has ever been able to roam. Unseen architects bend the pathways of light, their influence visible only in the arcs they leave behind. To trace their work, we must learn to read the quiet spaces between the galaxies. This is not the universe you believed you knew, but the one that has cradled you all along. Step upward from the hidden web into the familiar stars. Welcome to the map behind the map. Pause for title. Atmosphere swells, no narration, letting the moment breathe. We begin beneath the sky we know, a river of light that tempts us to believe the universe is drawn only in stars. Yet even within a galaxy's graceful arms, most of its mass hides in silence, shaping what we see without shining at all. Gravity bends light into arcs, tracing the unseen weight that sculpts the space between galaxies. Beneath the shining lies a hidden lattice, a cosmic scaffold on which the visible is delicately hung. Every galaxy turns inside an invisible sphere, bound by the quiet gravity of what cannot be seen. When clusters collide, the glowing gas slows, but the true mass glides onward without hesitation. Across millions of galaxies, tiny distortions align to reveal the faint pull of hidden structure. Even the universe's oldest light arrives bent, its ancient pattern blurred by the mass it has passed. Faint companion galaxies trace the paths carved by halos of matter that light alone cannot reveal. Voids speak in absence. Their silence marks where the web of the cosmos knots most loosely. Brightness is only a flourish. The true sentence of the cosmos is written in mass itself. From drifting clouds to cities of stars, the invisible keeps time for the universe's grand dance. Perfect rings of borrowed light betray the presence of the hidden giants shaping our view. Our instruments orbit patiently, gathering testimony from the darkness between the stars. Time becomes a lens, bending reality toward us through the slow arc of the heavens. Beyond the rainbow of sight, other spectra speak, revealing truths that light alone conceals. The great galactic giants glitter, but their grace rests on vast empires we cannot see. Between galaxies, flows a nearly invisible sea, its currents guided by unseen coasts. Even the smallest point can hold far more weight than its light would ever admit. To read the universe, we must first learn the language spoken in absence and in echo. We measure mass by the arcs it bends into light, reading the graceful curves of gravity like a script etched across the sky itself. Even the faintest stretch across millions of distant shapes whispers of massive halos too dark for any eye to see. When clusters collide, the bright matter slows and lingers, while the invisible mass slips through untouched. Flat rotation curves reveal a hidden hand, keeping the outer stars circling long after light would have let them drift. We stitch the sky into a single mosaic, each patch adding quiet weight to the map of the unseen. By reversing the lens, we coax warped images back into their undistorted, truthful form. Time itself can weigh a lens, delaying one image while letting another arrive first across the void. Matter streams along filaments in the dark, feeding the crowded clusters with what no light reveals. Galaxies gather in dark halos, glowing like lanterns suspended in a vast frosted glass night. Patterns sharpen where the visible and invisible align, bringing the universe's portrait into clearer focus. Halos follow hidden rules, linking their scale to a long history we can never watch directly. Even in the thinnest maps, the quiet absence of matter still bends the journey of light. The oldest light in existence carries the fingerprints of every structure it has touched along the way. From arcs and faint shears, we rebuild the mountain ranges of mass that no star can illuminate. Simulations let us replay the invisible choreography that built structure across cosmic time. We must untangle true distances or risk stacking shadows into shapes that never were. Through careful calibration, we strip away the smallest biases hiding at the map's edges. From the first photon to the final map, we guard the fragile signal from the crowding noise. When all layers agree, a suspicion becomes a measurement, and a measurement becomes shared knowledge. The finished map glows like a lantern in the dark, proving that even shadows have structure and shape. Galaxies are not just drifting, they recede faster with each passing age, as if space itself hungers for more and more room to grow. Type Ia supernovae burn with flawless brightness, serving as cosmic candles that let us measure the universe's accelerating growth. On the Hubble diagram, the curve bends away from straightness, a quiet but undeniable proof of some hidden cosmic push. The vacuum may not be truly empty. It could be restless, adding a constant, unseen pressure to the very fabric of space. A single equation of state value reveals whether this mysterious pressure remains steady across all of cosmic time. Ancient ripples in the early universe left a fixed ruler etched in the pattern of galaxies that still measures scale today. The first light of the cosmos holds peaks and troughs, each recording the long history of the universe's expansion. Space is a pliable fabric, and dark energy may be tugging at its weave, stretching it faster with every cosmic heartbeat. The most ancient galaxies bear the faint imprint of a faster expansion than we ever expected to find. Even the oldest light shifts in tone as it falls through evolving cosmic hills, reshaped by accelerating space. In the vast hollows between clusters, the subtle push of dark energy becomes most clearly and cleanly revealed. Data converge on a universe balanced between matter's pull and the relentless push of something we cannot see. From a hot, dense dawn to the cold, sparse night ahead, acceleration has been quietly rewriting the cosmic timeline. Our telescopes stand guard night after night, chasing the faint flare of explosions across the deep sky. Across the world, teams refine the evidence, narrowing the numbers that will define our cosmic fate. Different models of dark energy sketch diverging futures, some soaring into endless growth, others collapsing to darkness. We know our path now, a cosmos where all distances will grow faster, forever outpacing the past. Observation and theory now walk together, each confirming the other's story of an accelerating universe. From planets to the cosmic web itself, everything drifts on the same vast current of expansion. At the farthest horizon, light marks the line between what is known and what is still yet to unfold. The universe is not scattered without order. It's woven into a vast cosmic web, guiding galaxies along invisible gravitational threads. In the infant cosmos, tiny ripples in density swelled into great rivers of matter, shaping the skeleton of everything we see today. Superclusters form where mighty filaments meet, becoming vast cities of galaxies bound by gravity's enduring pull. Between those threads stretch immense cosmic voids, where matter thins to almost nothing and silence truly reigns. The web mirrors a neural network, its glowing nodes like thoughts where galaxies gather, as if the universe itself is thinking. Light moves through the scaffold, bending gently under the quiet weight of what remains unseen. Sky surveys chart the web in detail, turning scattered points of light into a connected map of cosmic structure. Simulations reveal how dark matter shaped the visible universe, weaving great bridges between distant galaxies. Galaxies flow along filaments like rivers, drawn toward the deep gravitational wells at each glowing node. Along each thread, density rises, guiding where stars will ignite and where darkness will still prevail. Even here on Earth, we are bound into this hidden lattice, part of the web we can barely perceive. Filaments tie clusters together across millions of light years, stitching the universe into one grand design. Even ordinary matter obeys the web's blueprint, drifting into its unseen channels over cosmic ages. Galaxies appear where filaments grow thick, blooming in the places where gravity's net is strongest. Over billions of years, the cosmic web stretched, merged, and reshaped itself, setting the course of the universe's story. At the end of each filament begins a vast void, its quiet expanse defining the edge of structure. Galaxy clusters emerge where filaments cross, pulled together by the deep gravity of the invisible. Heat maps trace the web's flow, glowing warm where matter converges, fading to cold where it scatters. The web is scaffold and story at once, its threads dictating the lives and fates of galaxies. From far enough away, the full architecture appears, an intricate universe written entirely in threads of gravity. When colossal bodies spiral inward, their final dance sends ripples through space-time, echoes carrying the memory of their last embrace. These waves stretch and squeeze the very fabric of space, smaller than a proton's width, yet immeasurable in meaning and reach. Laser-driven detectors watch for the faintest tremor, light catching a signal born in a collision unimaginably far away. Each wave tells a story, rising toward a peak, then fading into silence as the merged body settles into stillness. When neutron stars collide, they expose matter crushed beyond anything we can forge or imagine here on Earth. Sometimes the light and the waves arrive together, two messengers confirming the same moment in cosmic history. A quiet universal hum is built from countless ancient mergers, each too distant to ever be seen directly again. Some waves may be relics from the beginning, echoes from the first instant space learned how to stretch itself. Exotic relics such as cosmic strings could still send out ripples, leaving behind the faintest signatures in space-time. By timing each arrival across a network of detectors, we can pinpoint exactly where in the universe a wave began. Every new detection joins a growing archive, space-time's own library of the collisions that shaped the cosmos. After a merger ends, the newborn black hole rings like a struck bell, its final tone fading into infinite quiet. Pulsars keep time with perfect rhythm, but passing waves nudge their beat, revealing space-time's subtle distortion. Future observatories drifting in space will hear waves so long and low that Earth itself could never catch them. Different mergers sing with different shapes, each waveform a fingerprint of what met and how the meeting ended. Even the faintest signals hold meaning, whispers rising from the deep architecture of space-time itself. As black holes merge, they warp the shape of space, sending a ripple outward that will travel forever unbroken. Each year, our reach grows. More waves measured, more stories uncovered, more fragments of the cosmic puzzle aligned. We've learned to listen in new ways, not with ears, but with machines tuned to the faintest, quietest frequencies of the cosmos. Radio waves crossed the galaxy for thousands of years, carrying long-distance stories from stars, planets, and the dark between. Pulsars mark time like perfect clocks in space, their signals steady and sharp across unimaginable spans of time. Infrared light slips past cosmic dust, unveiling hidden births of stars, colliding galaxies, and heat still glowing in the dark. X-rays expose cosmic violence, black holes feeding in silence, tearing matter apart in brilliant bursts of energy. Gamma rays arrive as sudden, blinding flares, born in catastrophic moments that reshape entire regions of space. Spectra split light into its fingerprints, revealing motion, distance, and the elemental makeup of each celestial glow. Neutrinos slip through planets untouched, messengers from the hearts of stars, supernovae, and the dawn of the universe. Gravitational waves stretch and squeeze space-time, carrying signals from collisions too dark for light to reveal. Each instrument hears a different voice, but together they create the full chorus of the universe's song. The cosmos speaks in many tongues, waves, particles, and patterns that we are only beginning to translate. We filter the static carefully, separating the rare truth from the noise to hear meaning in the faintest signals. Even a delay in light's arrival tells a story, revealing mass, distance, and the contours of space itself. Earth's atmosphere shapes what we can hear, bending and filtering signals, and at times hiding them completely. The oldest light holds whispers from the beginning, if we can listen past the static to what it has carried. Clarity is born of patience, each careful refinement bringing us closer to the clean truth of a signal. When light, waves, and particles arrive together, the universe speaks more clearly, in harmony across its messengers. Every new detection is another note in space-time's quiet, ongoing symphony of creation and change. We too are part of this orchestra, our machines and minds tuned to catch the music of the stars. From our small blue world, we listen, and the universe answers in waves, in light, and in profound, resonant silence. Tomorrow's telescopes will rise from new worlds like the moon, listening farther and seeing deeper than anything built beneath Earth's skies. Space-based observatories will stretch across orbit, measuring gravity's faintest whispers with a precision Earth's surface could never achieve. AI will help decode the sky's complexity, detecting patterns and signals too subtle or vast for human eyes to recognize alone. Future sky surveys will map billions of galaxies, revealing the evolving structure and motion of the universe in unprecedented detail. Though Earth spins beneath the stars, our instruments stay locked on the cosmos, focused always on what lies ahead. On Mars, our instruments will listen beneath alien skies, free from Earth's atmospheric veil, hearing the universe in an entirely new way. Quantum sensors will feel the faintest tremors in space-time, mapping the unseen with a precision once thought impossible. Even the ocean's blackest depths will serve as observatories, catching ghostly particles from the very edge of creation. Swarms of tiny craft will ride the solar wind, sampling the charged breath of our star as they race through space. Autonomous eyes will decide where to look next, guided by patterns they have taught themselves to recognize among the stars. Around distant suns, we may one day build light catchers the size of worlds, gathering every possible ray. By linking the sky to Earth, we will trace how the vast cosmos shapes the fragile cradle we call home. Star shades will eclipse blinding suns, revealing the faint, waiting light of worlds that might be like our own. Spectra will expose the chemistry of alien skies, offering hints of life or the certainty of lifelessness. Probes may voyage to other suns, carrying humanity's questions far beyond the reach of our own footsteps. Simulations can unfold the universe's far future, when galaxies merge and even the brightest stars fade to black. Discovery will be shared, human insight balanced with the tireless precision of machine intelligence. We will guard the universe's memory in vaults against the moon's silent dust, preserving it for all time. One day we may gaze back upon the Milky Way, seeing our home as an island in a boundless sea. The future of discovery begins now, through the next curious eyes brave enough to look up and wonder. Beyond our star's light, the first messengers are already on their way, carrying our curiosity into the vast unknown where the next chapter begins. Beyond the horizon, the journey has only just begun.